Alright, let's look at the homework 4.3, problem number 8. Alright, so we want to find the interval of increase. Alright, so we need to look at the derivative. So f prime of x is equal to, derivative of that would be put whatever inside the natural log as a denominator. So x to the fourth plus 27 is on the bottom. Then take the derivative, put it on top because of the chain rule. So 4x cubed. Alright. Then we set this equal to 0 to find the critical number. And you can see that we just have to make top equal to 0. So x equals 1, x equals 0 is the critical number. Alright, so if you do a number line, and maybe I'll do it down here. Alright, so here's x equals 0. Alright, then we can try any number. So we'll try a sample number like x equals -1. Alright. So denominator is always positive. So if you plug in -1 cubed, so that's not a negative. So we have a negative sign there for the derivative. So this is, we're talking about the f prime. And if x is positive, so x equals 1, and the derivative is going to be positive. Alright. So interval increase would be starting from 0 to infinity, and then interval decrease would be -infinity to 0. Right, so let's type it in. Right, so it's a 0 to infinity, so I'll get a symbol. Alright, and then here is -infinity to 0. Alright, so so that's part A. Alright, so part B said to find the minimum value, local minimum values and local maximum values. So let's do that. Alright, so since we have only one critical number, and we can do a first derivative test. Alright, so at this point right here, alright, so this guy is decreasing. So if you visualize original function, and this guy is decreasing before 0 and increasing after 0. So which makes this guy local minimum, right? Then there's no local max, so local minimum. So we know that okay, at 0 is a function is going to be natural log of so maybe I should do that here. F of 0 is a natural log of 27. Right. So let's type it in. So we have a minimum value. So natural log of 27 is the minimum value. Right, and local maximum does not exist. Right, and then let's find the inflection points. Right, so we have to look at the second derivative. Right, so take the derivative again. Right. So derivative of this guy would be square the bottom. So you have x to the fourth plus 27 to the squared. Alright, and the 4 is just a constant, so I'll just put it here. Alright, then derivative of the top would be 3x squared times the bottom, which is x to the fourth plus 27, right, minus top is x cubed Then derivative of x to the fourth plus 27 is 4x cubed. Right. So if you clean this up, you have 4 here. Alright, so you have x to the fourth plus 27 squared. That looks okay. And then we're going to pull out, let's see, what's in common is x squared here. So x cubed here, so I'm going to take x squared. So we have x squared pulled out, and not much else. So you have 3x to the fourth plus, alright, 27 times 3 is what? 7 times 3 is 21, and 3 times 2 is 6, so it's 81. And then minus, it's 4x to the fourth power. Alright, so if you clean that up, so I'm going to actually erase some of it. Hold on a sec. Alright, so I'm going to clean this up a bit. So you have 4x squared. Then we have, let's see, so it's a 3x to the fourth, and so it's going to be a 81 minus x to the fourth power. Alright, then all over x to the fourth plus 27 squared. Alright, then we can set this guy equal to 0. So we can see that when x equals 0, we have the second derivative equal to 0. Also, x to the fourth is equal to 81, so it's a plus or minus. Alright, fourth root of 81 is 3. 3 times 3 times 3 times 3 is 81, right? So we have that. Alright, then we can just do a number line just to make sure that there's a concavity change. Alright, so it's at 0 and also negative 3. Oops. And a positive 3. Then we're looking at second derivative f double prime. Right, so we can try anything less than negative 3, so x equals like a negative 4. Right, then if you plug it in, you see that the denominator is always positive, and this is positive. So 81 minus negative 4 to the fourth power is going to be negative, so it's going to be negative. Right, so if x is between 0 and negative 3, so I'll try negative 1. So if you plug in negative 1 here, so this is positive, everything else is positive, so you have a positive sign there. Alright, then we can try x equals 1. Then again, 81 minus 1 is positive, so this is going to be positive here. Alright, then x equals 4. 81 minus 4 to the fourth power is going to be negative, so it's going to be negative. Alright, so you can see that the concavity changes at all 3 points. So we just need to find the corresponding y value. So f of negative 3 would be, right, plugging negative 3 there. So it's going to be 81 plus 27. So natural log of, let's see, 81 plus 27, 108. Right, and also f of 0, we did that, natural log of 27. And f of 3 is really the same thing as f of negative 3, so natural log of 108. Right, so we have a critical in the inflection point, so let's type it in. Alright, so inflection points are, alright, so we have, let's see, there are actually 3 of them. Let's see, let me double check. Alright, so let's see. Oh, actually, I made a mistake. Here is an inflection point here because there's a concavity change. Here, it's actually no concavity change, so there's no inflection point there. Sorry about that. And here is an inflection point. So we don't look at this one. Alright, so we have inflection points. Let's see. Alright, so it's going to be -3, comma, natural log of 108. And the other one is positive 3, natural log of 108. Alright, so we have that, and oh, I don't need the parentheses there. And alright, this will make it a little bit better. Alright, so we have that. Alright, so find the interval where graph is concave upward. Alright, so let's look at this. Alright, so you can see that it's concave upward between -3 and 3, and concave downward for the rest of it. So you have -3 to 3, and concave downward, so it's -infinity to -3. And let's see, you have to use so then union, and where's the union there? Union sets union, and 3 to infinity. Alright, that's that. So let's check, submit for testing. Alright, it came back and looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.